All right, welcome back to the deep dive.
Yeah.
Today we're going to really dig into something that, honestly, you don't always think about when you're first learning Java, but becomes super important once you're operating at, a more senior level.
Mm-hmm.
Thinking about, like, a senior software engineer role.
Right.
And that's the idea of Java packages.
Right.
It's like, when you start coding, you're just like, okay, I've got my class, I've got my main method,
Yeah.
and that's it. You just kind of throw everything in one place, right?
Yeah, it's all in one big pile.
Yeah, exactly.
Yeah.
But then things start to get complicated, especially, if you're working on bigger projects or with teams.
Yeah, you start to run into problems when you have like multiple people working on the same code base, and you might have two classes with the same name, and
Oh, yeah.
that's where packages come in to help you organize.
Yeah, it's like having folders, right?
Yeah.
Like instead of having all your files just scattered on your desktop,
Exactly.
you start putting them into folders, organizing them. So let's bring in our expert today who can really break down all the ins and outs of Java packages. Welcome to the show.
Thanks for having me. Glad to be here.
Awesome. So maybe just to start off, could you kind of like set the scene for us? Why are Java packages so important? And what are they all about?
Yeah, definitely. So as you said, when you're starting out with Java, packages might seem like an extra detail, but when you start working on larger projects, especially in a team environment, you quickly realize the importance of organization and modularity.
Mm-hmm.
So at a high level, Java packages are essentially a way to group related classes and interfaces together. This helps to organize your code, avoid naming conflicts,
Right.
and improve code reuse.
It's like, I'm trying to think of a good analogy. It's like, when you're moving to a new place and you've got all these boxes, you're like, okay, where do I put everything?
Right.
You wouldn't just throw everything randomly in any room, right? You'd be like, okay, kitchen stuff goes in the kitchen. Bedroom stuff goes in the bedroom. And packages are kind of like those rooms.
Yeah. Exactly. They provide structure and make it much easier to find what you need. And just like with your moving analogy, if you don't organize things properly, you're going to end up with a huge mess.
Yeah, and a lot of wasted time trying to find, the spatula or whatever.
Yeah, excellent.
It's in a box somewhere, but you don't know which one.
Right, right. So in the world of Java, these packages help us to avoid what we call naming collisions. So imagine if you're using two different libraries and both of them happen to have a class with the same name.
Oh, that'd be bad.
Yeah, it would be a problem. The compiler wouldn't know which class you're referring to.
Right.
And that's where packages come in. They act like namespaces. So a class in one package won't conflict with a class with the same name in another package.
Okay, so it's kind of like having different families, right? Like there might be two people named John Smith in the world,
Right.
but they have different addresses. So, if you're sending them mail, you wouldn't just write John Smith on the envelope.
Yeah.
You'd have to include their full address to make sure it gets to the right person.
Exactly. And that full address is what we call the fully qualified name of a class. So it includes the package name and the class name,
Got it.
which uniquely identifies it. Now, another advantage of packages is code reuse. When you group related classes together, it's easier to reuse them in other projects or share them with other developers. You can create your own libraries of reusable components, which can save you a lot of time and effort in the long run.
I see. So it's kind of like building with Lego blocks, right? You got all these different pieces that you can put together to create different things. And packages are kind of like those Lego sets. You've got a set of pieces that are designed to work together to achieve a particular function.
That's a great analogy. And just like with Lego blocks, you can mix and match different packages to build even more complex and sophisticated applications. And that's really where the power of packages lies.
I see. Now, you mentioned something interesting earlier about like these fully qualified names, right? And I've noticed that when you look at different Java libraries or frameworks, the package names often follow a specific pattern. Like you see things like com.google.json or org.springframework.boot.
Right.
So what's the deal with that? Is there a specific naming convention for packages?
Yeah, there is a common convention, and it's actually pretty clever. The idea is to use reverse domain names to create unique package names.
Reverse domain names. Okay, break that down for me.
Sure. So you know how every website has a unique domain name? Like google.com or amazon.com. Well, the convention for Java packages is to reverse that domain name and use it as the starting point for your package name. So for Google, it becomes com.google, and then you can add more specific components to that base, like com.google.json for their JSON library.
Oh, okay. So it's like starting with the biggest category and then getting more specific as you go down.
Yeah.
Kind of like those library cataloging systems, you know?
Exactly. And the reason for reversing the domain name is to avoid naming collisions. Since every company or organization has a unique domain name, this ensures that their package names are also unique.
Makes sense. So it's kind of like claiming your own little corner of the Java universe.
Exactly. And this convention helps to keep things organized on a global scale. When you're working with multiple libraries or components from different sources, you can be pretty confident that their package names won't clash because they're based on unique domain names.
Okay, so that's for like third-party libraries and stuff.
Yeah.
But what about the standard Java libraries, like the ones that come built in with the JDK? They seem to follow a slightly different pattern. Like you've got java.util, java.io, and so on.
Right, so those are the core Java packages, and since they are developed and maintained by Oracle, the company behind Java, they don't need to follow the reverse domain name convention because they're, the official providers of those core libraries.
I see. They've got dibs on those names.
Exactly. But even within those core Java packages, the principle of organization still applies.
Right.
Classes and interfaces are grouped together based on their functionality, making it easier to find what you need. So the java.util package, for example, contains all sorts of utility classes for working with collections, dates, random numbers, and so on.
I see. Okay, so this is all great high-level stuff. Let's get down to the nitty-gritty here. Like, if I'm sitting down to write some Java code,
sure,
and I want to put my classes into a specific package, how do I actually do that? What's the syntax? What's the magic word?
Okay, so the magic word, if you will, is package.
Package.
At the very top of your Java source file, before any class or interface declarations, you simply write package followed by the fully qualified name of the package you want to create. So let's say you want to create a package called com.example.myapp. At the top of your source file, you would write package com.example.myapp. And that's it. Any class or interface defined in that source file will now belong to the com.example.myapp package.
Okay, so it's like putting a label on the file saying this belongs here.
Exactly. And it's super important to note that this package declaration must be the first non-comment line in your source file.
Oh, okay, so it's got to be like right at the top.
Right at the top. Otherwise, the compiler will complain.
So, what happens if I forget to do that? Like, what if I don't include a package declaration in my source file?
That's a good question. So technically, there is a default package in Java.
A default package?
Yeah. If you don't specify a package for your classes, they end up in this unnamed default package.
Okay.
Now, while it might seem convenient for small, simple programs, especially when you're just starting out, using the default package is generally considered a bad practice.
Oh, why is that?
Well, for starters, it goes against the whole principle of organization and modularity that we've been talking about. Everything just gets dumped into this nameless void,
Right.
which can quickly become a mess as your project grows. And more importantly, it can lead to naming conflicts if you ever try to integrate your code with other libraries or components.
Ah, I see. So unless you're working on a really small self-contained project, it's always a good idea to explicitly define a package for your classes. It helps to keep your code organized, avoids naming conflicts, and makes it easier to reuse and share your code.
Got it. So packages are like good hygiene, right? It might seem like a hassle at first, but it keeps things clean and prevents problems down the line.
Exactly. It's a good habit to get into early on.
Okay, so we've declared our package using the package keyword. Now, how does this relate to the actual files and folders on our computer? Like, where do these Java source files and the compiled.class files actually go?
That's another crucial aspect of packages. The package name that you declare in your source code directly corresponds to the directory structure on your file system.
Okay, so it's like a mirror image.
Exactly. So if your package name is com.example.myapp, then you need to create a folder structure that matches that hierarchy. You'd have a folder named com, inside that a folder named example, and finally inside that a folder named myapp. And your Java source files for this package would go inside that myapp folder.
I see. So it's kind of like how the Postal Service organizes mail, right?
Right.
They have these sorting facilities with different bins for different zip codes and areas. And each piece of mail gets routed to the correct bin based on its address. So in Java, the package name is like the address of the class.
Exactly. And just like with the Postal Service, if the address is incorrect or if the directory structure doesn't match the package name, the compiler and the JVM won't be able to find your classes.
Ah, that makes sense. So what happens when we actually compile our code?
Yeah.
Like, how does the Java compiler, javac, handle this relationship between packages and directories?
So when you run the javac command to compile your Java code, it looks for these package declarations at the top of your source files. And based on that, it automatically creates the necessary directory structure, if it doesn't already exist, and places the compiled.class files in the appropriate folders.
Okay.
So it's kind of like the compiler is acting as a file organizer for you.
Convenient.
It's making sure that everything's in the right place. Now, by default, javac will create these folders starting from the current directory, but you can also specify a different output directory using the davo-d option.
Oh, I see. So that's useful if you want to, like, keep your source code separate from your compiled output.
Exactly. It's a good practice to have a dedicated output directory for your compiled classes, especially in larger projects.
Okay, so we've compiled our code, and we've got all these .class files neatly organized into their respective packages. Now, how do we actually run our program? Like, how do we tell the JVM which class to execute, especially when it's part of a package?
So to run a Java program that's part of a package, you use the Java command just like you would for a simple program. But there's a catch. You can't just use the simple class name anymore. You need to use the fully qualified name of the class.
Right, the full address.
Exactly. So if your main class is myapp, and it's in the com.example.myapp package, you would run it like this: javacom.example.myapp.
I see.
The JVM will then use this fully qualified name to locate the correct .class file within the package hierarchy.
Okay, so what happens if I mess up the directory structure? Like, what if I accidentally put a class file in the wrong folder? Will the JVM still be able to find it?
No. If the directory structure doesn't match the package declaration in your source code, the JVM won't be able to find the class, and you'll get a runtime error.
Oh, okay. So it's really important to make sure that everything is in sync, right?
Yep.
The package declaration in the call, the folder structure on the disk, and the fully qualified name that we use to run the program.
Exactly. Everything needs to line up perfectly for the JVM to be able to locate and load your classes.
Got it. Now, let's say we've built this awesome application, or maybe it's a library with a bunch of useful classes, and we want to share it with others, or maybe even use it in other projects ourselves. We don't want to just copy a bunch of loose .class files around, right? That would be messy and error-prone.
Right. And that's where Java archive files, or JAR files, come into play.
JAR files? Okay. Tell me more about those.
So a JAR file is essentially a way to package all of your compile.class files, along with any other resources like images or configuration files, into a single compressed file.
Okay.
It's kind of like a zip file for your Java code.
I see.
And this makes it much easier to distribute and deploy your code. Instead of having to copy a bunch of individual files, you just copy the JAR file, and everything is neatly contained within it.
So it's like a little suitcase for your Java classes, right?
Exactly. It keeps everything together in one place.
Okay. So how do we actually create these JAR files?
So the Java JDK comes with a command line tool called, you guessed it, jar.
JAR, all right.
And you use this tool to create, view, update, or extract the contents of JAR files. To create a JAR file, you typically use the C option for create, the V option for verbose output, which means it'll show you what's being added to the JAR, and the F option to specify the file name of the JAR file you want to create.
Right.
So, for example, if you want to create a JIR file called myapp.jar that contains all the .class files in your com.example myapp directory, you would run a command like this: jar cvf myapp.jar com.example myapp.
Okay, that seems straightforward enough.
Yeah, it's pretty simple. And the wildcard character, the asterisk, is used to include all the files within that directory.
I see, I see. Now, I've seen different variations of the jar command options, like sometimes with single dashes, sometimes with double dashes. What's the story there?
Yeah, that can be a bit confusing.
It is.
So historically, the jar command used single letter options like C, V, and F, which is a common convention in Unix-based tools. However, as Java has evolved, they've started to adopt a more modern convention of using double dashes for longer, more descriptive options like create, verbose, and so on. So you might see both styles of options being used in different examples or documentation,
Right.
but they essentially do the same thing.
Got it. So it's just like different dialects of the same language.
Exactly. And the jar command is smart enough to understand both styles.
Okay, that's good to know. Now, you mentioned that JAR files can be used to package not just libraries, but also entire executable applications. So how does that work? Like if I have a JAR file with my entire application, how do I actually run it?
So to create an executable JAR file, you need to specify which class contains your main method, the entry point of your application.
Right.
And you
Okay.
do this using the E option when you create the JAR file.
E for executable, I presume.
Exactly. So the command might look something like this: jar cfee myapp.jar com.example.myapp.myapp come example myapp.
Okay.
So we're using the C, F, and E options here. The E option specifies the fully qualified name of the main class, which in this case is com.example.myapp.myapp. And then to actually run this executable JAR file, you simply use the java jar command followed by the name of the JAR file.
Okay, so it'd be like java.jar
Exactly.
and that's it. The JVM will then read the JAR file, find the main class that you specified using the AV option, and execute it.
Perfecto.
Awesome. Now, we've got our code organized into packages. We've packaged it into JAR files. But how does the Java system actually know where to find these JAR files? Like if I'm using a third-party library or even my own library that's packaged as a JAR file, how do I tell the compiler and the JVM where to look for it?
That's a great question, and it brings us to the concept of the class path.
The class path. Okay, this sounds important.
It is. The class path is essentially a list of locations where the compiler and the JVM will search for .class files or JAR files that aren't part of the core Java libraries.
I see.
So it's like a roadmap for finding your external dependencies.
Okay, so how do we actually set this class path?
There are a couple of ways to do it. The most common way is to use the -she option, or its longer equivalents class path or dash class path when you're running the JAVAC or Java commands.
Okay.
So you would simply list the path to your JIR files or the directories containing your .class files separated by colons on Unix-like systems or semicolons on Windows.
Right.
For example, if you have a JAR file called mylib.jar in a directory called libs, you would include it in your class path like this: java-cp libs mylib.jar com.example.myapp.myapp.
I see. So it's basically saying, hey, JVM, if you need to find any classes that aren't part of the standard libraries, check inside this mylib.jar file.
Exactly. And you can include multiple JAR files or directories in your class path. Just separate them with colons or semicolons.
Okay, that's handy. Now, what if I have, like, a whole bunch of JAR files in a directory? Do I have to list each one individually?
No, you don't. You can use a wildcard character, the asterisk, to include all the JAR files in a directory. So, for example, if you have all your JAR files in a directory called libs, you could use something like this: java-cp libs com.example.myapp.myapp.
Oh, okay. So that's much more convenient than typing out the name of every single JAR file.
Exactly. But there is a caveat here.
Yeah.
When you use a wildcard, the order in which the JAR files are loaded is not guaranteed.
Oh, okay. So that could potentially cause problems, right? Like if you have two JRR files with different versions of the same library, the JVM might pick the wrong one.
Right. That's a potential issue, especially if you have conflicting dependencies. And this is where proper dependency management becomes really important, which is a topic for another deep dive, perhaps.
Perhaps. We'll put a pin in that one. Now, besides using the -ab option, is there another way to set the class path?
Yeah, you can also set the class path using an environment variable.
An environment variable. Okay.
Yeah.
How does that work?
So every operating system has this concept of environment variables,
Mm-hmm.
which are basically key value pairs that store system-wide settings. And there's an environment variable called classpath that you can set to specify the default class path for your Java applications.
I see.
So if you set the classpath environment variable, you won't need to use the -apt option every time you run your program.
Right.
The JVM will automatically use the value of the classpath variable.
Okay, so it's kind of like a global setting for the class path.
Exactly. However, while it might seem convenient, setting the classpath environment variable globally is generally discouraged, especially if you're working on multiple projects with different dependencies, because it can lead to conflicts and unexpected behavior. It's much safer and more manageable to use the less sheepy option on a per project or per execution basis.
Right, so keep it local.
Exactly. And if you do need to use the classpath environment variable, make sure you set it specifically for the project you're working on and unset it when you're done.
Okay, so we've covered a lot of ground here. We talked about how to organize our code with packages, bundle it into JAR files, and tell the JVM where to find everything using the class path. Now, let's shift gears a little bit and talk about access control. We've touched on this before with the public and private keywords,
Right.
but there's also this thing called package access. What's that all about?
Yeah, so package access is kind of like the default access level in Java.
Default.
Yeah, if you don't explicitly specify an access modifier for a class, method, or variable, it automatically gets package access. And what this means is that it's accessible to all other classes within the same package, but not to classes outside the package. So it's kind of like a middle ground between public and private.
I see. So it's like having a private club, right? Like only members of the club have access to the facilities.
Exactly. It's a way to control access within a specific group of classes.
Okay. Now, you mentioned that package access is the default. So what happens if I accidentally forget to specify an access modifier?
That can be a potential issue.
Oh, how so?
Well, if you, for example, forget to declare a variable as private, it'll end up with package access. And this means that any other class within the same package will be able to access and modify that variable, which might not be what you intended. So it's always a good practice to be explicit about your access modifiers, even if you're just working within a single package.
Okay, so it's better to err on the side of caution. Right?
Absolutely.
Okay, so we've talked about public, private, and package access. Now, are there any other access modifiers in Java?
Yeah, there's one more. Protected.
Protected, okay. What does that one do?
So protected is similar to package access, but it also allows access from subclasses.
Subclasses, okay, so we're getting into inheritance here.
Right. So if you declare a member as protected, it's accessible to all classes within the same package, as well as any subclasses of the class that declares that member, even if those subclasses are in a different package.
Okay, so it's kind of like package access plus inheritance.
Exactly.
Okay, that makes sense. So we've got 4 access modifiers: public, private, package access, and protected. And they give us a lot of fine-grained control over who can access our classes, methods, and variables.
Exactly. It's all about encapsulation, hiding the implementation details and exposing only what's necessary to the outside world. And this is a crucial concept for building well-structured and maintainable applications.
Absolutely. Now, one last thing about packages that I wanted to touch on is the idea of importing classes. So we've seen how we can use fully qualified names to refer to classes in other packages.
Right.
But that can get pretty tedious, especially if you're using a lot of classes from different packages.
Yeah, it would. And that's where the import statement comes in.
Import, okay.
The import statement allows you to use the simple name of a class from another package without having to write out the fully qualified name every time.
Okay, so it's kind of like a shortcut.
Exactly. It's like telling the compiler, hey, I'm going to be using this class a lot, so just assume that I mean this specific class when I use its simple name.
Got it. So how do we actually use the import statement?
So you simply write import, followed by the fully qualified name of the class you want to import, and end it with a semicolon. For example, if you want to import the ArrayList class from the java.util package, you would write import java.util.ArrayList. And now you can just use ArrayList in your code without having to write java.util.ArrayList every time.
Okay, that's much cleaner.
Yeah, it is. And you can import multiple classes from the same package just by writing separate import statements for each class.
Right. Now, what about importing like all the classes from a package? Is there a way to do that?
Yeah, you can use a wildcard character, the asterisk, to import all the classes from a package.
Oh.
So for example, to import all the classes from the java.util package, you would write import java.util.
I see. So that's convenient.
Yeah, but it's generally recommended to be more specific with your imports.
Oh, why is that?
Well, importing everything from a package can sometimes lead to naming conflicts if there are classes with the same name in different packages that you've imported. And it can also make your code a bit harder to read because it's not immediately clear where a particular class is coming from.
I see. So it's kind of a trade-off between convenience and clarity.
Exactly. So if you're only using a few classes from a package, it's better to import them individually. But if you're using a lot of classes from the same package, then using a wildcard import can save you some typing.
Makes sense. Now, what if I import 2 classes with the same name from different packages? Like, how does the compiler know which one I'm referring to?
That's a good question. And unfortunately, in that case, you'll get a compiler error.
Oh, no.
Because the compiler won't be able to disambiguate which class you're referring to.
So how do I fix that?
Well, you have a couple of options. One option is to use the fully qualified name of the class when you're referring to it in your code. So instead of just writing date, for example, you would write Java java.util.date or java.sql.date, depending on which one you need.
I see.
And the other option is to simply not import both classes.
Right.
If you know you're only going to be using one of them, just import that one and use the simple name.
Okay, so be mindful of your imports.
Exactly.
Okay, so we covered a lot about packages and imports.
We have.
And I think this has been a really helpful deep dive into this topic. Any final thoughts or key takeaways that you'd like to leave our listeners with?
Yeah, sure. So I think the key takeaway here is that Java packages are not just some arbitrary organizational structure. They're an essential part of the language, and they play a crucial role in building well-structured, maintainable, and reusable Java applications. So as you progress in your Java journey, especially if you're aiming for a senior level position, make sure you have a solid understanding of packages, how to use them effectively, and all the related concepts that we've discussed today.
Right.
Because it's definitely something that will come up in technical interviews.
Absolutely. So if you're, cramming for those interviews, pay attention to this stuff. It's not just academic.
It's not.
It's really practical, real-world stuff.
All right. Well, thank you so much for joining us today and sharing your expertise on Java packages.
My pleasure. Thanks for having me.
And thank you all for listening to The Deep Dive. We'll see you next time.